Good afternoon. Myself Laveena Sehgal from IT Department, IIMT College of Engineering. So here I'm going to discuss about sorting in data structure. So we will study about what is sorting and its different types. It is basically the most important topic from any exam point of view. Either you are going from government exam or for some different exam academically for placement. It is the core subject of your computer science engineering also, and sorting is the most important topic. So first, before starting the sorting, we have to learn about what is sorting. If I talk about sorting, it basically refers to the operation of arranging data in some given particular sequence, such as in increasing or decreasing order. Sorting basically tells us about to arrange the data elements in a particular list in the form of ascending or descending order. So basically it arranges the set of items or data items or elements in a particular list or array in a particular sequence. So most of the activities we require sorting. If we go for any kind of work in academically, or if we arrange some data in the sequence of numerically or alphabetically, you have to use sorting algorithms. So many applications require sorting. So we perform sorting when they don't have an inefficient sorting algorithm. So here we will So here we will learn also about different types of sorting with its algorithms and examples. Sorting basically refers to the arranging of data in a particular format. If I have data or elements in a list, suppose in unsorted array, suppose 4, 5, 12, 15, this is an unsorted array. If I found some element in a particular sequence, so we have to use sorting. For example, अगर हमें if I have to find a name of a student in a class according to the roll number, if it is in serial order, it will be easy to find the particular student because it is in the sorted array or sorted list. If it is in the shuffling or in unsorted array, it will be difficult for me to find that particular student. So, sorting is nothing but arranging the data in ascending or descending order. Either we arrange our data in alphabetic numerical order or numerical order. Sorting arranges data in a sequence which makes searching easier. With the help of sorting, we can make our search easier. If I have to find some particular data in a bulk of data, or I have to mine our data. So sorting helps us to find it easier. So uh, if I talk about real life scenarios of sorting, so in real life you can see your telephonic directory or dictionary. It is a major example of sorting. Why so? Because the telephonic directories to the telephone numbers of people sorted by their names so that the names can be searched easy. If you find out your telephone diary in your homes or in your office, it will be easy to find because it has been arranged in a sorted way from A to Z. Similarly, if I have to find the meaning of a particular word in a dictionary, it is also in a sorted form. So it helps so dictionary helps to store words in an alphabetical order so that the searching of any word becomes easy. I can easily find out the meaning of that word very easily. So next comes to the sorting terminologies. Before starting proceeding sorting technology, we have to learn some terminologies which comes occurs in sorting. So these are the two basic properties of sorting terminologies. That is, one is in-place sorting, another one is stable. What in-place sorting tells us? In-place sorting Means if an sorting algorithm does not require an extra memory space except for few memory units, then that algorithm is said to be in place. It means this process saying, or it means that we don't require any modified space in the memory for storing that sorted array. So an in-place sorting algorithm uses constant extra space for producing the output, modifies the given array only. We sort the list by modifying the order of the element within the list. So in-place basically uh, comes under when we don't require extra space for storing. When we don't require extra space for storing the our list. So, for example, in-place sorting, insertion sort and selection sort are in-place sorting as they do not use any additional space in memory for saving their sorted list. Next is not in-place sorting. In some sorting algorithms, the program requires space which is in more than or equal to the elements being sorted. Sorting which uses equal or more space is called not in place sorting. Uh, for example, merge sort and counting sort is an example of not in place sorting. So, next, another one more property comes under sorting, that is stable. If the sorting algorithm preserves the relative order of any two equal elements, then the sorting also is stable. Means if I have a list of data element, for example 4 I can't compare 4 with 4 for a sorted. I can compare like 4 5 6 7 8, but I can't compare two similar equal elements in a list. So that property is called stable in sorting. So next comes to there are two different or basic categories of sorting methods, which are internal and external sortings. When all data is placed in memory, then sorting is called internal sorting. Um, Means when we are storing the whole data list in a memory, that is your internal sorting. When all data needs to be sorted cannot be placed in memory at a time, the sorting is called external sorting. When we are using external sources for storing our array list, then it is called external sorting. External sorting is used for massive amount of data. When we want to store large amount of data, or if I have large amount of data elements in a list of array, then I use external sorting. If I have less data elements, then I use internal sorting. Merge sort and its variations are typically used for external sorting. Some external storage like hard disk, CG, etc. is used for external storage. So this is a picture you can see here. Type, comparison based, index based, name of the different types of sorting, and time complexity, how much time it will be take. So uh, before uh, before going to study the sorting and its types and different algorithms in sorting, we should know what is the criteria for analysis of sorting algorithm. In every sorting algorithm, you have to follow these five criteria. Means these five conditions. You have to compare the data elements in the list of array. If first element is larger than the second element, you have to arrange in a sorted form. Means either in ascending order or descending order. For that you have to do swapping from one element to another element. So extra memory is used. This is the third criteria for sorting the sorting algorithm. We have to use extra memory. Fourth criteria is adaptive. Adaptive means if the sorting takes minimum time, the list is already sorted, then we must say that the sorting technique is adaptive. If I don't have to sort the data elements in our array list, means that array list is already sorted, we don't require in either ascending or descending order, then we can say it is adaptive. Stable, I already discussed about the stable property. So basically, stable tells you the describe the relative order of any two equal elements, then the sorting is also stable. This is this technique does not change the order of elements with the same value. For example, if you see here, out of comparison based techniques, bubble sort, insertion, and merge sort are stable techniques. These three techniques are stable techniques. For example, selection sort is unstable as it may change the order of elements with the same value. For this example, consider this array have four elements. So capacity of this one is 1, 2, 3, 4 is 4. Memory storage is 4. So I can assign this A0, A1, A2, A3. These two have same values. It will be difficult for us to arrange the elements or to compare or swapping with the same value. In the first iteration, the minimum element found is 1 and it is swapped with 4 at 0 position. Means if I swap 4 with swap, this is the order will be order of 4 with respect to 4 at the first will change. The only sort order is change. Similarly, quick sort and heap sort are also unstable. Out of non-comparison based technique, counting sort and bucket sort are stable techniques, whereas Redis sort depends upon the underlying algorithm used for sorting. So now comes under the sorting application. So we can use sorting mm, in many fields and in many areas. When I am going to prepare a list of students for a particular class in a college, I need the sorting application. Means to prepare a list of student ID, names and scores in a table for easier checking. To prepare a list of scores before later grade assignment. To produce a list of horses after a race. Means you have to give a position or medal first, second, third in a sorted way. Payoff calculation it will be easier with the help of sorting. To prepare an originally unsorted array for ordered boundary searching. It is with the help of sorting, our searching becomes very easier to find either student ID, roll number, or name because it has already been arranged in the sequence order, either numerically or alphabetically. So here we can find some different methods, or you can say here mm, different types of sorting. There are so many sorting types: selection sort, insertion sort, bubble sort, shell sort, which is a faster sorting method, and quick sort, radic sort, bubble sort, heap sort. There are so many methods of sorting of different types. Now we will study how it works. How it works, we will study about one by one. First comes selection sort. The selection sort performs sorting by repeatedly putting the largest element in the unsorted position of the array to the end of this unsorted portion until the whole array is sorted. Means it tells us about the process. Selection means we have to select the minimum element in the starting or largest element in the last position of the array, and after that we have to compare that element with the minimum value of element in the array at a particular location. It is similar to the way that many people do their sorting. So here you can find out the algorithm of selection sort. First you have to define the minimum element in the entire array of unsorted data elements, and swap swap with find out the location of smallest element in an array list and swap with the first element. While the unsorted position of the array has more than one element, first find its largest element, swap with the last element, and reduce the size of the unsorted position of the array by 1. Here you can see an example also. This is an unsorted array of data elements C. Starting from the last one. This is the minimum element. You can assign this is the minimum element. And first find out the largest element in the array, that is 17. First compare this element with this one and swap it. So 17 comes here in the last position and 7 comes here. So your last position will be fully occupied now. Now next comes to the 7. Compare with next another largest element. So 14 comes here. Next comes and swap with 7. Next comes with 3. Compare 3 with the largest element, that is 10. It comes to here. Then comes to the 1. Then compare 1 with the largest element, that is 7. It comes to the here. Similarly comes to the now rest of the elements comes in the sorted array 1, 2, 3, 5, 7, 10. So this is the final sorted array after passes 4, and we also call these passes as an iteration. Here you can see the program for implementing this sorting. Next comes to the bubble sort. Bubble sort examines the array from the start to finish, comparing elements as it goes. Bubble sort means it, as its name suggests, it works like a bubble. Means suppose you have 10 elements in an array. You have to compare first element with second element. If second element is largest than the first one, then it is okay. If it is smaller, then swap that element with the first element. Anytime it finds a larger element before a smaller element, swap the two, as I said already to you. Similarly, in this way, the largest elements are passed towards the end. The largest element of the array therefore bubbles to the end of the array. Till the we can passes the going or iteration passes till we get the sorted array of elements. Then it repeats the process for the unsorted portion of the array until the whole array can be sorted. So basically, bubble sort works on the same general principle of shaking a soft drink bottle. Right after shaking the contents, a mixture of bubbles and soft drinks distributed randomly. So as the bubbles get lighter, then the soft drink rises to the surface, displaying the soft drink downwards. This is how bubble sort got its name, because its smaller elements float at the top and the largest elements in the sink to the bottom. So here you can find out the algorithm to solve the bubble sort. Define the entire array as the unsorted position of array. So suppose we have an unsorted array of elements. So while the unsorted position of the array has more than one element, we have to compare every element with its neighbor element and swap with the first one. Because if second element is larger, then it's okay. If it is smaller, then compare it with first one and swap it. So we reduce the size of the unsorted position of the array by 1. Bubble sort is very simple sorting algorithm used in data structure. This sorting algorithm is comparison based algorithm in which each pair of adjacent elements is compared. Adjacent means its neighbor elements is compared and the elements are swapped if they are not in order. So this algorithm is not suitable for large amount of data where we use massive data. This is the word scale complexity, ON scale, where n is the number of items. So here you can see an example of bubble sorting. So starting from the, so this is the list of data elements in an unsorted array. 14, 2, 10, 5, 1, 3, 17, and 7. This is neither in ascending order and nor in a descending order. This is totally unsorted array because it is now not like 1, 2, 3, 4, 5, 6, 7, neither 10, 9 in this order. So how we will start bubble sorting? We first compare 14 with 2. So 2 is smaller than 14. So then we swap these two elements. Right. Next comes to the 14 10. 10 is smaller than 14. We swap this element with this element. Next comes 14 with 5. We swap this element with this one. Next comes 14 with 1. We swap this element with this one. 14 with 3. Then swap this one. 14 with 17. 14 with 17. It will remain same. Then comes to this one. We swap this one. 14 7. This one. Now next comes to the second pass. 2 5 is good. 2 5 is in a sorted way. Compare 10 with 1. 1 comes this one. Compare 10 with 3. Swap this one. Then compare 10 with 14. It is similar. Compare 14 with 7. Then we have to, because 7 is smaller. Then 14 and 17 will be similar. 2 and 1. 2 and 1. Compare these elements that tells us we have got it the sorted array. So the last one is 1, 2, 3, 5, 7, 10, 14, 17. We find here we can find the sorted array of data elements. You can find another and one example also. Bubble sort starts with first two elements, compare them to check which one is greater. 13 is greater than 14, so we will remain same. But 33 is greater than 27, so we have to swap this element. 27 is smaller than 35, it will be. Then last one, 35 and 10. 10 is smaller than 35, so then we have to swap. The new array should like this one: 14, 27, 33, 35, 10. In next comparison, we have to again comparison 14, 27, 33, 35. We have to compare till we get the sorted array. Again we have to compare, then we have to become 10, 14, 27, 33, 35. This is the final sorted array we require in every iteration after every day. So this is the bubble sort program you have to implement using C. So this is the structure as a bubble sort. You can see your calendar. Another shortcut example of bubble sort algorithm: if list is greater than list I plus 1, swap it as the list, and if return list, means you have to compare with two elements, first and second. If the second one is smaller, then swap it with first one, and swap it with first one and compare with next iteration. So if we talk about complexity analysis of bubble sort, complexity analysis tells you the how much time and space is required to solve the problem. So here is the following are the time and space complexity for the bubble sort algorithm. Worst case time complexity, big O notation represented by this one. Best case, big omega. Average time curve, big theta. Space complexity is in the space complexity. This is because only a single additional memory space is required for temporary variable. We don't require extra memory for storing this data elements. Next, we talk about insertion sort. Insertion sort is basically it tells you the in-place comparison-based sorting algorithm. Means in this process, we inserting the elements, means we comparing the either smallest one or largest one, which can be maintained is always sorted. For example, the lower part of an array is maintained to be sorted. An element which is to be inserted in the sorted sublist has to be find its appropriate place, and then it has to be inserted there. Here the name insertion sort. The algorithm is not suitable for large amount of data, as its average and worst case complexity are of bigger notation scale, where n is the number of items. So here you can see an example of insertion sort: 14, 33, 27, 10, 35, 19, 42, 44. Insertion sort compares the first two elements. It compares with 14 and 30 are already in ascending order. For now, 40 is in the sorted sublist. Right? We no need to change 14. Then it moves ahead and compares 33 with 27. So and finds that it is not in the correct position. Here first we compare 14 with 33. So it is already in sorted array. Now we come move next to position. Compare 33 with 27, which is not in the correct position. It swaps 33 with 27. Also checks all the elements of sorted sublist. Here we see that the sorted sublist only one element 14. You can see here is in sorted sublist we have only one element, that is 14. So we compare this one and swap 33 with 27. After swapping, you can find here. Now there are two elements in sorted sublist. Now again compare 33 with 10. So swap 10 with 33. So 14, 27 and 10. You can do swapping till we get the sorted array. So here also makes 27 and 10 are unsorted. Swap this one. So 14, 10 and 27. So 10, 14, 27, 33, 35, 19, 42. The process going on until the unsorted values are covered in a sorted sublist. So this is the insertion sort algorithm. So first step insertion sort is that you have to find out the first element, compare with the second one. If it is already sorted, then leave it in a sorted element subsorted array. Otherwise, you proceed ahead. Pick next element and compare with all the elements in the sorted sublist. Shift all the elements in their particular position either in ascending or descending order. Insert the value repeated until list has been sorted. Complexity analysis of insertion sort. So worst complexity is big on notation and best complexity is big on omega. Average complexity is this one. Means this time and space we require to solve the problem of insertion sort. Last one, thanks. If anyone has a